This is a video to help you get through 7.2 of Hawks. So one thing that might really help is there's a Desmos calculator. It's desmos.com/scientific. And it looks like I have 9 combination 6 divided by 9 permutation 6. So I'm going to go to my calculator, go to function. There's the NCR. This is a combination formula. So we have 9 and we use a comma 6. Close my parentheses, divide that by permutation 9 comma 6. And if you want to write this as a fraction, just hit the fraction thing over here on the side. And that's 1/720. Here's another one where we can use our Desmos calculator. We have 31 factorial over 15 times 13 minus 5 factorial. So I'll just go to Desmos and type this in just the way I see it. And by the way, factorial, that's when you count back or you multiply counting backwards, like 31 times 30 times 29 all the way down to 1. So here's 31. There's my factorial button, and then I'm going to divide that by 15 parentheses around 13 minus 5, close my parentheses, and factorial. Let's go back, and now this is in scientific notation, and I don't think, I'm going to double check that question first of all. 33 minus 5. Oh, okay, I messed up. There we go. What's nice about Desmos is I can go back and just move my mouse to wherever I need to edit. Okay, 1798, that looks better because I did the practice. There we go. I did practice and I didn't see any really big answers on that. 1798. Next we have, let's see, here's one. It's the president of a college asked the fraternity to submit a list of 7 students to serve as ushers at a school function. They have 18 students who are available. And how many ways that can the students be chosen? So one thing between learning the difference between a permutation and a combination. A combination is when we choose a group out of so many individuals, and the order of the people doesn't matter. Permutation is if the order matters. Permutation, think of position. The position matters. It's like winning a race. Permutation, you have first, second, third place. Combination, it's just a combination of a group of people, and they don't have any particular placement. So I'm going to use my combination formula. I'm going to go to Desmos. I have NCR. That's N, choose R. That's what the C stands for. I have 18. And I believe I'm choosing 7. 31, 8, 24. 31, 8, 24. Here's the one with the ducklings. Now with ducklings, order does matter. You have, because they're lining up in a line. You have 8 ducks, and there are 8 different positions for each duck. Like, let's say the first duck lines up, and okay, the first, well, so the duck first in line, there's 8 different choices because you have 8 ducks. And then after that, you have 7 choices because there's already a duck in the first of the line. And then the third duck, then you have 8 different choices. So you could look at this as a factorial. Let me write this out for you. Okay. 8, 7, 6, 5, 4, 3, 2, 1. Okay, this is we can think of this as 8 factorial because the first in line, there's 8 different ducks that could be first. And then after that duck gets in line, there's 7 ducks left. And then 6, 5, 4, 3, 2, 1. 8 factorial. Or you can also think of this as a permutation. You have 8 ducks in 8 positions. 8 permutation 8. There's 2 ways to think of this problem. So I'm going to go to my calculator, and whichever way I approach this, I will get the same thing. So on Desmos, I can go to eight factorial, which I get 40,320, or I can do permutation 8, comma 8. So if you see any problems like that mention a fundamental principle of counting, often they're talking about just multiplying possibilities together. Or in some of those, actually, you can use the permutation formula. So 4,320, 40,320. On the next one, we're going to use our Desmos calculator. This is for combination 3 divided by 4 permutation 3. And another thing you can do is you can go up and edit a previous step. If you run across a really similar problem, and I just used my mouse to move up and edit this step. So we got 1 out of 6. And I'm going to go back when. So you can type your answers in as decimals, but I found it a lot easier just to use the fractions rather than having to type in decimals. The next one, I have 29 games. Each game results in 2 outcomes. Find the total possible number of outcomes. So if you have 29 games, in the first game you could win or lose, okay, 2 outcomes, times the results of the next game, which would be 2, times the result of the next game, which is 2 again, and so on and so forth. You wind up multiplying 12 or 2 to itself 29 times. Or I can think of 2 to the power. There's if I go back to my main menu, here's an A to the power B button, 29. And now I might be able to copy and paste this number for my answer from Desmos. Let's see if this works. So I'll copy and I'll see if I can paste that. That would save me some time. Here we go. Submit answer, and oh, we found a shortcut. So if you have a really long answer and you need to, you can go to Desmos and you can put that in as the copy of that into your certify. This one uses the fundamental theorem of counting. We have a new surround system. There's a TV, surround system, and a DVD player. You have 7 different TVs, 5 surround systems, and 9 DVD players. So basically with the fundamental, with with these problems, you're just going to multiply all three of your different choices together. So that's the fundamental principle of counting. I have 7 TVs, and I'm going to multiply that. And I can just go back. Here's my multiplication. And looks like 5 surround sounds and 9 DVD players. And I have 315 possibilities. Next one. Here's another one where we can use our Desmos calculator. We have 16 factorial. Go to function. Here's factorial. Divide that by 13 factorial. And I believe it says 4 minus 1 factorial, which is just basically 3 factorial. You can type in 4 minus 1, that's 3, and then factorial. And that gives me 560 as my solution. Next one is a very similar problem. So when I go to Desmos, it looks like I have 19 factorial over 16 factorial. So I'm just going to change that 16 to a 19 and change that 13 to a 16. And I have a very similar that question that gave me 969 there. Here's another duckling problem. So when you get to the problems with the ducklings, that's basically 6 factorial because 6, 5, 4, 3, 2, 1. So we have 6 factorial, which is 720. And here's another one, 39 factorial divided by looks like I have 40 or 19 times 42 minus 5. I better check this because if I screw up, then I'm going to have to redo a similar question. 42 minus 5 factorial. Yeah, that looks like. And I get 30 or 78. Okay, so I each semester, if I don't edit the certified quizzes on Hawks, I just get what's sent from Hawks is like a default curriculum. So if you have trouble with a particular lesson and there's some problems in there that are really giving you trouble, you can just email me and I can edit that curriculum for you, change the certify portion of your assignment a little bit. And I hope this helps those of you that are struggling with this section.